Today we're going to be talking about what graphing points in 3 dimensions looks like. So you'll notice that I have a coordinate space on the plane. We can call this Euclidean space because instead of just having an x and a y-axis, we also have a z-axis. The arrows are pointing in the positive directions, and we'll talk about how we name the different axes in another video. But the principle behind two-dimensional space transfers over to three-dimensional space. So each point in a coordinate space has its own set of coordinates because now there's an x-axis, a y-axis, and a z-axis. We call them triples rather than coordinate pairs. We call them coordinate triples. And here's the point 2, negative 3, 1. So here's the x-axis. Along the x-axis, we go 2 in this direction. And then we go negative 3 along the y-axis. And then we go 1 up the z-axis. So I'll spin this so that you can see what that looks like. It's 2 in the x direction, negative 3 in the y direction, and then 1 in the z direction. The axes could be labeled better, but I don't know how to make this software label the axes better. So essentially what you should be doing is going parallel with the x-axis, then going parallel with the y-axis, then going parallel with the z-axis, according to whatever this is. And this is 2, negative 3, and positive 1. Now I'll show you another one. This coordinate is 3, 3, negative 2. So going from the origin, we call 0, 0, 0 the origin now. We go 3 along the x-axis, 3 along the y-axis, and then negative 2 down to there. Now typically we'll only graph the point, but I'm graphing all of these in order to show you exactly how we know that that point belongs there. If we have a vector in this space, what it does is it starts from the origin and it goes to that point. So if a vector started at 0, 0, 0 and ended at 3, 3, negative 2, then it would have vector form. It would have components 3, 3, and negative 2. So this is what three-dimensional space looks like when you're graphing it. What we try to do in order to graph it by hand is we'll draw, starting in the x direction, we'll draw 3. Then we'll go parallel to the y-axis, 3. And then we'll go parallel to the z-axis, negative 2. That doesn't mean that we're going to end up at the same, just because it's here is negative 2 on the z-axis doesn't mean we'll actually be here. This would represent going 0 in the x direction, then 3, then negative 2. We have to go 3 in the x direction, then proportionally 3 in the y direction, and then proportionally 2 in the z direction. It is hard to tell exactly where this point is because we can't, without actually rotating the space, you can't tell whether it's close to you or far from you, and that's what depth perception is for in real life. But this is the process that you're following, going 3, then 3, and then down 2. Thanks.